Consider the function x squared plus 3x plus 5 over x plus 1. So this is of the form a quadratic over a linear. We've not looked at functions like this yet. State the equation of the vertical asymptote. Well, vertical asymptotes always happen when the denominator is equal to 0. So in this case, x plus 1 is equal to 0, which means the vertical asymptote is x equals negative 1. Now, in the required prior knowledge, we performed this division. And we did the division to find the quotient, which was x plus 2, and the remainder, which was 3. Now, if you've done this investigation, which I hope you have, you've already done this investigation and used the Desmos activity provided, you will have seen that we get this graph when we do that. Now, what do you notice about this graph? Well, the graph of the red function here, that's our function, and then this blue dashed line is the line y equals x plus 2. What do you notice about the function and that blue line? Well, hopefully you've noticed that the function is getting closer and closer to that blue line, but that means that blue line is an asymptote. It is a line that the function approaches as x goes off to infinity. As x gets bigger and bigger, or more and more negative, the function is getting closer and closer to that blue line. It never quite reaches it, but it gets closer and closer to it. That means it's an asymptote, and we call this type of asymptote, which is not a vertical asymptote, it's not a horizontal asymptote, it is an oblique asymptote. So there is an oblique asymptote at y equals x plus 2. Can you explain why this function approaches x plus 2 based on this, as x tends to infinity? Well, as x tends to infinity, think about what happens here. X squared plus 3x plus 5 over x plus 1 is equal to x plus 2 plus 3 over x plus 1. Well, that's going to tend to, as x tends to infinity, this bit here, the 3 over x plus 1, tends to 0, because x plus 1 gets enormously big. So 3 over an enormously big number becomes 0. So this whole thing tends to just x plus 2. So rather than tending to a number, a value, it's tending to a linear function. So we end up with this oblique asymptote, this diagonal line rather than a horizontal line that this particular function approaches. And this happens with quadratics over linears. We get these oblique diagonal asymptotes rather than horizontal asymptotes. If you carry on with the investigation, there is another function that you can type into the Desmos activity and have a look at what happens, and you will see exactly the same thing coming out from that.